In today's lecture, we will talk about the medicinal of the mefloquine. We will talk about the structure of the mefloquine. We will tell you people the trick through which you guys will learn the method to draw the structure of the mefloquine in a very easy way. Yes, in a very easy way. Then I will talk about the mechanism of action. After that, IUPAC naming and synthesis in detail, in simple and easy way. Okay? Well, so let's get started from the very first point, that is the mefloquine structure. How to draw the structure of the mefloquine. And what is the trick? Structure is this. Now let me go through the trick through which you guys will learn the way to draw the structure of the mefloquine in a very easy way. The trick is, don't memorize the term, the drug mefloquine single. You must memorize this drug mefloquine plus piperidine. Why? Very simple. Because of this, if you memorize by this way, that you are learning the name mefloquine plus piperidine, you don't learn, okay? Don't go through just mefloquine. This is the trick that will help you guys now, right now, to which you will then draw the structure in a very easy way. So for now, consider that mefloquine is not simply mefloquine. It is actually mefloquine piperidine. Okay? What? Mefloquine piperidine. So let me add the complete name of the drug. It is actually the trick name, not the complete name, the trick name. Trick name is mefloquine piperidine. That's it. This is our trick name for this mefloquine drug. So now by means of this trick name, you will go through this structure. Well, how like? Just concentrate. Mefloquine is actually a single word. Now split this into three. Me, flow, and queen. Got? Very simple. Now just take the me. Consider this me for methanol. Methanol, a carbon having hydroxyl group, functional group attached to it. And flow, consider this like fluorination. And you will find the fluorination here, CF3, CF3, trifluoromethane. And let me write it here, F. Quinine, we guys know that quinine is actually the ring, having two rings with a nitrogen heteroatom attached to this two ring. So this is our actually the quinine ring. So now, from this name and from this trick name, from this part of this trick name, just write and draw the structure of mefloquine. How like? Quinine ring, we know quinine ring. What is the quinine ring? Very simple. This is actually the quinine ring. Two rings attached with a nitrogen heteroatom. This is quinine ring. Then go for the fluorination in methanol. For the fluorination, remember this particular portion and this portion for the fluorination. And again, remember there will be three fluorine and along with the carbon. So this fluorination will be trifluoromethane. What? Trifluoromethane. Here is nitrogen, CF3 and CF3. So you got this structure now. Now let's come towards the me. Me is methanol. So methanol should be here. COH. And now just go for the trick name. That is, this portion is done of the trick name. Mef is done, mefloquine is done. Now go for the piperidine. I told you guys, if you remember this mefloquine, if you memorize this mefloquine through this trick name, mefloquine piperidine, then it will become very easy for you to draw the structure. So now this is becoming easy for me to draw it easy in a very easy way. Why? Because I'm learning through this trick name, mefloquine piperidine. So if I split this mefloquine into me, flow, and queen, I will draw this now. So now remaining is piperidine, so I will draw the piperidine. And I know the structure of piperidine is, and I hope you guys also know, this is the structure of the piperidine. Nitrogen with a hydrogen, and then a complete benzene-like ring. You can say cyclic ring. Uh, this is now done. So this is actually piperidine. I just did what? I just joined this piperidine with this carbon. So now what will become? Here is in front of us the entire structure of mefloquine being drawn. I just go for the valency satisfied like this. So here we have cyclization, and then we have delocalization, bonds and bonds, and like this. The name of the mefloquine is actually done in short. I hope you got the understandings. So how we got this name? Now again, told people in the beginning, just recapping, you can say that mefloquine is a drug with us. We are asked in exams to draw the structure of the mefloquine. So how would you draw? Very simple. I told you guys, learn this trick name. Through this trick name, you will become able to draw the structure of the mefloquine. So what is this trick name? Trick name is mefloquine piperidine. So then I'll just take mefloquine first of all. First of all, split this mefloquine into me, flow, and queen. Then attach piperidine with a drawn structure. So what is me is actually methanol, carbon having hydroxyl, and flow is fluorination in the sense of trifluoro, okay? And we have quinine, that is quinine ring. So first of all, so we are supposed to draw the quinine ring. Then after that, we will go for the fluorination. We will attach fluorine here and here, in just like a trifluoromethane, okay? Then we will have a bond to which we will attach methanol, carbon and hydroxyl. I told you, remember the strict name. In the strict name, one is done. Mefloquine is done. This mefloquine word, we split this into three parts. Then we just draw this structure. Now we're coming towards the piperidine. So the remaining bond with the carbon is, there are two bonds. One will be for the hydrogen, second will be for the piperidine. So draw the piperidine here like this. Your mefloquine structure will become completely drawn. Now let's go towards the mechanism of action. I hope you got, okay? If still you have confusion, you can ask us in the comment box. We'll come for your answers very soon, inshallah, as we get time. So we have mechanism of action now. Mechanism of action, regarding mechanism of action, it's believed that regarding mefloquine's antimalarial activity, it is actually a schizonticide, and this mefloquine is also acting on the heme. So now, first of all, let me tell you people about the schizonticidal mechanism of action, how it is acting on the schizont, or how it is schizonticidal mefloquine. Very simple. When we indicate mefloquine, it actually destroys these schizons. Now, let me give you guys a little bit a background of this schizont, where it is coming from. Simple. The vector, like a female anopheles, in that there is this parasite available, the plasmodium. So that is actually called sporozoite when it is in the anopheles. When it is interred into the blood of the humans like us. So what will happen in that, in us, then it will move through the blood to the liver. In the liver, it will change its shape. Then that sporozoite will be called as schizont. Now, when we give this mefloquine will destroy these schizons. So then the pathway, the cyclic pathway, which I have discussed in our separate lectures, like you can search that lecture. The lecture name is Anti-Malarial by Dr. UUT. So if you are learning the drugs plus cyclic pathway, if you want to learn this cyclic pathway in detail, so you must search life cycle of malarial parasite or simple life cycle of plasmodium. You will get this life cycle complete. So then watch that. Okay. So for now, simple. Sporozoites will be converted into schizons in the liver. So when we give mefloquine drug, that will actually destroy these schizons. That's it. So then we have hypnozoids here. So you will get learning of regarding hypnozoite in that video. Well, coming to the point, simple. Schizonticide is actually the mechanism of action of the mefloquine. When we give mefloquine, that will come and that will destroy these schizons. So then the remaining structure, the remaining pathway will be blocked. And another action is actually on the heme. So now what is happening here? As the plasmodium enters into the body, so it is getting its way to the blood cells. So where it will break the hemoglobin into heme and globin. So now heme is available here. Now this heme will be converted by some enzymes of the plasmodium into hemozyme. So that hemozyme, then this will be used to cause fever, splenomegaly, and anemia in humans. Okay, so in the organism in which it is actually getting into. So in short, plasmodium is causing all these through this pathway. So when we give mefloquine will come and will bind with the heme. So what will happen then? Very simple. The heme will not be converted into hemozyme, and this heme, if it is not converted into hemozyme, it is actually toxic for the plasmodium. Simple and easy. Just concentrate once again. Hemozyme and heme, these two things are supposed to be remembered. Hemozyme is causing fever, splenomegaly, anemia, means it is toxic for us. And heme is toxic for the plasmodium. So if we inhibit conversion of heme into hemozyme, so we will get a kind of achievement to block the pathway or the action of the plasmodial parasite. Got? So that is what will happen. We will get no fever, no splenomegaly, no anemia. Means in short, we just actually somehow protected ourselves from the malaria. This is in short mechanism of action of the mefloquine. So now let's come towards the iupac synthesis. Well, this iupac synthesis, this remaining part is actually supposed to be available when you just do have a kind of approach that is on this contact number +92 340 80 600 81. So you can buy the remaining lecture if you want. Okay, if not, this is the for you. Means regarding IUPAC and synthesis, you are supposed to contact us and buy the remaining portion of the lecture. Thank you for watching.